Today we're going to talk about accuracy and precision. So please find your accuracy and precision notes in your packet, and we're going to go ahead and get started. So you might have heard the word accuracy before, or accurate, right? And so you might know in everyday life what you think that means. You might have also heard the word precise or precision, and you also might know what that means in your everyday life. But in science, sometimes we have very specific terms for words that we use kind of any way we want in everyday life. And accuracy and precision are two of these examples that we need to talk about, that we have very definite definitions for in science. So the first one that we're going to talk about is accuracy. And you'll notice that some things on this slide are bolded and underlined. That's what you're going to want to write down in your notes packet. So accuracy is how close a measurement is to the actual value. All right, so let's talk real quickly about this. So we know that there are hundreds of football fields all over the world, especially in the United States, right? And all of those football fields are supposed to be 100 yards. But if we took all the football fields in the world and we lined them up, they probably aren't all exactly 100 yards, right? They're supposed to be 100 yards, but some are probably more accurate than others, meaning that the Cleveland Browns probably have a more accurate football field that's closer to 100 yards than, the Worthington Rec Center, right? Because in the Cleveland Browns, in professional football, that number needs to be more accurate because it really matters, right? Precise or precision is how close measurements are to each other, right? So how close are all of the football fields to each other? And they probably are pretty close in size, right? Probably only off by a couple of centimeters or so. So they're probably fairly precise. So we have accuracy, how close the measurement is to the actual value, and precision, which is how close measurements are to each other. So one of the best ways to look at accuracy versus precision is through looking at bullseyes. So if you've never shot darts before or bow and arrow in gym class, this is a dartboard, and your goal is to hit this red dot in the center, right? That is your goal. And so when we look at this first graph, we can see that it's accurate, right? If our goal is to be in that red circle, those are definitely accurate. They're in the red circle. Precise is how close those are to each other. Well, when I look, all of those black dots are really close to each other. So this bullseye is accurate and precise. In the next bullseye, it's not accurate, which means it's not close to that center that we wanted, that known value, but it is very precise. Those black dots are still very close to each other, even if they're not close to the bullseye, which we were hoping for. Accurate but not precise is a great example here. Here, those four values are fairly close to the bullseye, but they are not that close to each other. And lastly, not accurate and not precise, we kind of have a hot mess over here, right? All of those black dots are spread out, they're not close to each other, and they're not close to that known value of that center part. So I'm going to ask you to test yourself real quickly. I want you to look at this accuracy versus precision, and I want you for each of these bullseyes to evaluate whether you think it's accurate, yes or no, or precise, yes or no. So please go ahead in your notes, pause the video, and go ahead and make your best guess from what we just learned about whether these are accurate and precise. So hopefully you took time to pause the video and you have decided whether these are accurate or precise. So remember, accurate is how close they are to that center part. So here, I don't think those black dots are very close. So I'm going to say no, this is not accurate. But those black dots are really close to each other. So I'm going to say yes, this is precise. In our next one, we'll notice that all 5 of those dots are in the bullseye, right? So that means that they're very accurate, and they're all also very close to each other, so they're also precise. Lastly, you'll notice that we have our 5 dots kind of spread all over the place. One is kind of near the middle, one is in the middle, one's kind of near the middle, but then 2 are really far away. So I would say this is not accurate, and it is definitely not precise. Those values are not close to each other. So in science class, we're not often going to be looking at bullseyes. What we're really going to be looking at is data. And is our data accurate and is it precise? So here is the little practicing with real data we're going to do. It says the following measurements were made to determine the density of a material whose value is supposed to be 1.24 grams per milliliter. And then here are my 3 trials, right, of the data I did get. It says, what is the accuracy of these results? Well, the value that we were supposed to get, or the known value, is 1.24 grams per milliliter. All right? And in this class, we're going to say that if something is within 0.1, so a tenth place, it is accurate, right? So we want to know, are these 3 values within 1/10 of 1.24? And they are, right? 1.20 is only 0.04 away, and then these 2 are only 0.02 away. So I am going to say that these results are accurate. So I have written down these results are accurate because they are all within 0.02 grams per milliliter of the known value. So these are fairly accurate results. Now we want to know about precision. Remember, precision is how close these points are to each other. So I want you to think for a second, are these very precise? So hopefully you said yes, they're fairly precise because they're all within 0.02 grams per milliliter. So I'm going to write my response now. So I wrote these results are precise because they are all within 0.02 grams per milliliter of each other, and they're close in their values. So this is what I've written. I think that this set of data is accurate and precise. So now we're going to look at another set of data, and this prompt says the following measurements were made to determine the density of a material whose value was supposed to be 3.75 grams per milliliter. And we have our information here. Remember, I said that we decide if something is accurate if it's within a tenth place, right? Well, these are not within a tenth place. They're almost a full gram per milliliter more than our expected value. So these results are not very accurate. So I've written these results are not very accurate. All of the trials are about 1 gram per milliliter away from what they were supposed to be. Remember, it was supposed to be 3.75 grams per milliliter, and they're not anywhere close to there. So this is not a very accurate data set. Now let's look at precision. Remember, precision is how close those values are to each other. Well, I got 4.74, 4.75, and 4.76. So think to yourself, do those seem like they're close together? Does this seem like precise data, even though it's not accurate? Hopefully you said yes, for sure. This looks like precise data. So go ahead and write your reasoning, and I'm going to write my reasoning too. So I wrote, this data is precise because the values are very close together, right? They're only 0.01 gram per milliliter off. So this is precise but not accurate data. So on this last page, I'd like you to create your own bullseye. So please go ahead and create your own bullseye. We're going to do the first one together. Here's precision and here's accuracy. It wants us to put 4 dots onto this bullseye. And so I'm going to go ahead and do that. So it has to be high accuracy and high precision. So that means my 4 dots should be close together and close to the wanted value. So I'm going to go ahead and give you a second. Please pause the video and complete the rest of this. So hopefully you pause the video and you have time you've had time to go ahead and write your answers here. I'm going to go ahead and share with you what I have also gotten. So for high precision and low accuracy, remember those are going to be close together, but not close to the wanted value. So there is my example of high precision and low accuracy. Now the next one I'm going to do is high accuracy and low precision. So those are ones that are close to the value, but not close to each other. And lastly, I'm going to do low accuracy and low precision. So those are ones that are kind of all over the place. So hopefully this makes sense and you feel like you better understand accuracy and precision when we use them and how we use them with our data sets.